Welcome to The Explainer. Today, we're going to peel back the layers on a piece of tech that has absolutely changed the game for running software, Kubernetes. We're going to break down how it takes the absolute chaos of managing modern applications and turns it into control. To really get why Kubernetes is such a big deal, you have to picture the world before it existed. For big companies, managing all their applications was basically a full-blown operational crisis. People would describe their systems as a house of cards, so fragile that you were always afraid one little thing would make the whole thing just collapse. All right, let's really dive into that world for a minute, the world before orchestration, because you need to understand the pain points, the things that were so broken they forced the creation of something as powerful as Kubernetes. Just try to imagine managing thousands of these little application containers completely by hand. A huge traffic spike hits your website? Well, someone has to manually and slowly start up new servers. A container crashes at 3 a.m., your app is just down until some poor engineer gets paged, wakes up, and fixes it. This wasn't just a little inefficient, it was totally unsustainable. So the solution that emerged wasn't just, a slightly better tool. It was a whole new philosophy, a completely different way to think about and interact with our infrastructure. And that answer came in the form of something called container orchestration. You can think of it like an autopilot for your applications. It's this intelligent, automated system that handles everything: deploying, scaling, networking, the whole shebang. It lets you stop worrying about individual machines and start seeing your entire data center as one single giant pool of resources. And this, right here, this is the fundamental shift. The old way, the imperative way, was like giving someone turn-by-turn directions to get to your house. Take a left, then a right, go 3 blocks. It's tedious, and if they hit a roadblock, they're stuck. The new declarative way is like just giving them the address. You just state the destination. I want 3 copies of my app running. And you let the system, like a GPS, figure out the best way to get there and automatically reroute if there's a problem. You declare the what, and Kubernetes handles the how. So how does it pull off this magic trick? It's all powered by something called a reconciliation loop. And it's a really simple but incredibly powerful idea that just runs nonstop. Kubernetes is always 1. Observing what's actually happening right now, 2. Comparing that to what you said you wanted, and 3. Acting to fix any differences. This simple loop is the engine that drives all of Kubernetes' automation. So how is this whole system actually put together under the hood? Let's take a quick look at the basic anatomy of a Kubernetes cluster to see what the moving parts are. When you zoom out, a cluster is actually pretty straightforward. You can think of it as having 2 main parts that work together. You've got a brain that does all the thinking, and you've got the muscles that do all the heavy lifting. Okay, so let's start with the brain. In Kubernetes speak, this is the control plane, and it is, for all intents and purposes, the boss of the entire operation. It orchestrates everything. So inside this brain, you've got a few critical components. The API server is like the front door. All communication goes through it. etcd is the cluster's memory. It's where your desired state is stored. The scheduler is like a dispatcher, figuring out the best machine to run a new task. And the controller manager? That's the guy running all those reconciliation loops we just talked about, making sure reality always matches what's in the memory. All right, so you've got the brain, now you need the muscle, and that's where the worker nodes come in. These are the actual computers that have the power to run your applications. On every single one of these worker machines, there's a little agent called the kubelet, and its only job is to listen for instructions from the control plane, from the brain. The kubelet then uses the container runtime to start and stop your containers, while kubeproxy handles all the complicated networking to make sure they can talk to each other. So we've seen the parts, right? The brain, the muscle. Now let's put it all together. We're about to see one of the most powerful, almost magical features of Kubernetes in action: its ability to heal itself. But first, real quick, you need to know about the most basic building block in this whole world: the pod. A pod is the smallest thing you can create, and it's basically just a little wrapper around your application's containers. But here's the thing, you almost never create pods directly. That's kind of like micromanaging. Instead, you use a smarter, higher-level thing called a deployment. You just tell the deployment your desired state, like, hey, I want 3 copies of this pod running all the time, and it takes care of the rest. Okay, so let's set the scene. We've told our deployment we want 3 replicas of our application. That's our goal, that's our desired state, and it's now locked into the cluster's memory. So everything is humming along nicely, and then life happens. Maybe a server just dies, or a bug in our code makes one of our application pods just vanish. It crashes.
Instantly, the real world, the actual state of our cluster, has changed. We now only have 2 replicas running, and that does not match our desired state of 3.
And this is where the magic happens. Remember that reconciliation loop? It's always watching. The controller manager immediately sees the mismatch. It's like, whoa, wait a second. I'm supposed to have 3 of these things, but I only count 2. And it just takes care of it. It automatically takes corrective action. The scheduler finds a new healthy machine, and a brand new pod is started to replace the one that died. Within seconds, we're back to 3 replicas. The actual state, once again, matches the desired state. And the best part? No human had to lift a finger.
So that self-healing thing is really cool, but what does it actually mean? Why does this matter so much to developers and to businesses? Well, it's a total game changer.
I mean, this is it. This is the whole story. Every single one of those painful, manual problems we talked about at the beginning has a direct, automated solution in Kubernetes. Downtime becomes self-healing, slow manual scaling becomes automated scalability, wasted money becomes efficiency. It replaces fragile, fire-prone systems with resilient, automated ones. And that lets engineers build cool new stuff instead of just putting out fires all day. So in the end, Kubernetes isn't just about running containers more efficiently. By taking all that insane complexity of modern infrastructure and just automating it away, it frees us up to think bigger. It leaves us with this really exciting question. When your infrastructure can literally heal itself, what will you build next?